roundabout. When I was, neither of my parents went to college. I didn't have any particular mentors or anything in school. As a kid, I had two loves. One was reading, and the other was tennis. So I thought I'd either be a professional tennis player or a novelist, one or the other. First a tennis player when I was young, and I played tennis until college, actually, competitively. And then I learned about, I read everything as a kid, kind of. I mean, as I say, I didn't have a particularly academic background. My family, parents didn't go, they encouraged education, but they didn't go to college. They weren't highly educated, so I read, but I mostly read fiction because I like stories and storytelling and all that kind of stuff. And then I was editor of the school newspaper and those kind of things. So I liked writing, I liked reading, and I liked storytelling. All of that told me I should be a novelist or a tennis player. I was playing tennis all this time competitively. And I became somewhat disillusioned with becoming a novelist in high school. Probably it's more complicated than what I'll say, but I always, your memory always kind of focuses on one thing. And so for me, it was a high school literature class where clearly I was given the wrong novel to read. The novel is, you can guess at it if you want, but I mean, this novel basically convinced me that if that's good literature, forget it. I really didn't like it. And this was a novel in high school. I don't know, 15 years old or 16 years old. It's a famous novel, but it shouldn't be read by a 15-year-old, at least this 15-year-old. It's Moby Dick. So I don't know if you've ever read Moby Dick, but Moby Dick is a big, thick novel. And the problem with it isn't that it's thick, that's okay. But what I remember most is that there's a chapter, but the problem with reading it for a 15-year-old is we don't understand, as 15-year-olds are. I didn't understand as a 15-year-old's metaphors. And the whole novel is basically a metaphor. So if you don't understand that, it's kind of boring. If you don't know what a metaphor is, which I didn't. And there's a long chapter which kind of is now, I would say, the white whale's point of view compared to it's this duel. And basically, if you don't understand metaphor, it was a 100-page chapter describing in great detail everything about this white whale. I found it so incredibly boring. I wanted to find something else to do. So that's my kind of dramatic one. But I think I kind of became disillusioned with writing when I was kind of high school age. I was always good at math, math, I didn't know science yet, and didn't pay much attention to it. I was good at it, it was easy for me, kind of like most scientists at that stage they were. And I won some math contests when I was young and so forth. But I never thought of becoming a mathematician. That didn't occur to me. Coming from a kind of lower middle class, working class family, I thought I had to do something where I'd make a living. Also, being a novelist, I realized when I was in high school that it was hard to make a living. So I decided I probably had to be an engineer. That's the only thing I could kind of see. Because I was doing this on my own, nobody was really guiding me. The closest was my tennis coach, no teacher. My tennis coach used to realize that the other players on the tennis team would come to me with their hard problems. And I was more academic, clearly, and so he got the impression I must be smart and needed some direction, so he pushed me to do something more academic with my life. So anyway, I decided I'd study engineering. I had the quirk that my birthday is in January, And at that time, in the Los Angeles City Schools, they had graduating classes both in mid-year, in January, and in June. I decided to study engineering. I was still kind of thought I might still pursue tennis, and I went out for freshman tennis in Berkeley. I came to realize at that stage when I was playing freshman tennis that there were other tennis players that were much better than I was, which I didn't run into in high school, and that it took a lot of time. And since I was studying engineering, you had labs in the afternoon, and you were supposed to go to tennis practice before school in the morning and then again in the afternoon. They were very serious about it, but I couldn't do that because I had, after half a semester or something, I dropped tennis. So I was only going to be an engineer. And except the problem is that I hated engineering more than I hated Moby Dick. Not, I'm joking kind of, but I like engineering now. So, but as a freshman, what I had to study in engineering in Berkeley, a good school, I had 2 courses in engineering, and then I had a course in math and chemistry and physics, and something else. I don't. French literature thing, and I dropped tennis. I dropped tennis somewhere along the way, and the 2 courses in engineering were engineering drafting, which now I like because you can look at a drawing and see what things are like. But if you're studying engineering drawing, at least in the class I had, the teaching assistant would come up and criticize my arrowheads and things like that, and that was too tedious for me, so I hated that. Then the second course I had in engineering was surveying, where you got this transit, and you went on the campus and you looked at building. You had an assignment to look at buildings and measure how high some window was or something, and that was kind of fun for about one afternoon because I learned about this transit and learned how to use it, and then it was completely boring and also embarrassing as a kind of shy freshman standing on the campus looking through this thing with other kids, walking by and pointing at you was bad. So I realized quite quickly that I from that, which isn't the real picture of engineering, but that's what you take in as a freshman, I decided I wasn't going to be an engineering student. And at the same time I was studying, I had freshman physics, and at that time in Berkeley, they were discovering all the elementary particles. And so I was in a kind of environment of discovery, and that kind of captured me quickly. Freshman physics probably wasn't that exciting, but it was easy enough for me, so I did that fine. So I switched to physics from after this one semester, the rest is kind of history. As a undergraduate student, I was good at physics, clearly people, and so I had a academic advisor named Owen Chamberlain. Turns out he's a Nobel Prize winner. He wasn't at that point, for discovering the antiproton. And he got the Nobel Prize in 1959. I'm pretty old, so I was an undergraduate a few years between the time he discovered the antiproton and he won the Nobel Prize. That's when he was my advisor. And he suggested, because I was, the classes, undergraduate classes I was taking ahead of where I was in school, that I should do some research, which wasn't as common then among undergraduates as it is now. But his research was up at the Lawrence Berkeley Radiation Lab, which was called the Rad Lab then. And now, if you go to Berkeley and you go up to the radiation lab from the campus, there's a little shuttle bus that goes back and forth every 15 minutes. But when I was an undergraduate, you were on your own to get up to this lab, and if you've ever been there, it's up this hill, windy hill, and you either hitchhiked or walked. And it's enough of an ordeal, so when you went up, you didn't want to completely turn around and come back right away. And so I used to go up, I don't know, Tuesday or Wednesday afternoons, and when I was going to do my research, and I'd get all the way up there, and typically he was too busy for me. Yeah, he was too busy for me, clearly because he was in the middle of this period between showing people that he discovered the antiproton. So, but I didn't. He was a nice advisor, but he didn't have time for me. So I was up there and didn't know, didn't really want to. I didn't have to worry about school too much, and so I wanted to do something, but I didn't want to just walk right back down the hill. But I just walked up or hitchhiked up, whichever way I did. And so I used to wander around the radiation lab. And at that time, they had several particle accelerators. And the biggest one was the Bevatron, where they discovered the antiproton, but it was very businesslike there. So I'd go in there, and they had the radiation areas you couldn't go to, but nobody would pay much attention to me there. So I wandered up to the 184-inch cyclotron, which was the classical cyclotron, biggest one ever built, in Berkeley, but it was no longer the main accelerator. They had the Bevatron, which is higher energy and can produce antiprotons. And at the cyclotron, I wandered around, this is all my memory, and I walked into the control room and found somebody that would actually be friendly to me. I was this undergraduate walking around with nobody to talk to, and it was an older guy who ran the machine. And so he would sit in this control room and run the machine, and he actually would talk to me, so I chatted with him. I kind of became friendly, and after going up to the lab and having the same kind of problem several times, where I'd wander up and find somebody to talk to, I started asking him how he ran the machine, and he started showing me, and I had this objective that I was going to learn how to run this accelerator. And there's a bunch now there's a computer, so, of course, but at that time it was knobs, maybe a couple of buttons, knobs. And one of them would be energy, that would be the strength of the magnets and so forth. And so he would tell me, okay, I'm going to change the energy set. And there's a big knob that says energy or magnetic field or something that you use to change the energy. And he would twist that knob, and then I would notice he'd also go tweak to some other knob. And I thought that was kind of curious. And I asked him why he did that, and he'd say, oh, because it works better. And of course he had an incredible amount of experience with his machine. So he knew that when he did this, when he switched the field of the magnets, he had to do something else also to make the machine work right. But he he just knew it from experience. And so that all intrigued me. It was the first big puzzle. And so I made a big diagram of what he was doing. It had all these knobs, and that was one variable, and then what he did to it. And I didn't really know what I was doing, but I was basically looking at this thing as what it is. It's a control system. And in a control system, in an ideal control system, the matrix is all diagonal, and the things you want to vary are one-to-one in the diagonal term. But if you have off-diagonal terms, then that's the equivalent of these extra knobs that you twirl. I didn't know that language exactly, but I actually put it in matrix form and realized what all these off-diagonal terms were. I started lecturing him about all these off-diagonal terms, and came to realize that he was actually not just somebody that learned how to run the machine, but he was an older guy that had been important during the whole era when in Berkeley they were doing the research that led to the atomic bomb. So he was one of these guys. And later I saw in pictures, when you saw the Lawrence and Macmillan, he was always in one of the people in those pictures. So he somehow, I don't know how, drifted to running a machine, because that's what he loved to do. But he understood these things. So basically he got a big bang out of that. And so I spent a lot of time with him and learned also about all the experiments and read all the papers that came from the experiments there, and knew all the equipment, all this through kind of just hanging out, because I didn't have any real I wasn't really doing any work. So this all happened during mostly in my junior year, but maybe into my senior year. And then it was time to apply to graduate school. And I wanted to I wanted to go to graduate school somewhere where they did particle physics, because they were discovering all these particles. And I really wanted to go to Berkeley, because that was the place where the most particles were being discovered, because they had both the accelerator and these big bubble chambers and equipment and stuff. But I was told that they didn't like to take their own undergraduates in graduate school. It's common. It's also true at Caltech. We don't. And so I applied to Princeton and Caltech and other places. And then my advisor, who I did get to talk to once in a while, said, "Why don't you at least also apply to Caltech, to Berkeley?" And I did, and they admitted me to Berkeley. So I stayed in Berkeley for graduate school for this obvious reason. I knew what I wanted to do, and in graduate school, because I had undergraduate school there, the exams you take in graduate school, you're very well directed. You're very well trained for that. So graduate students mostly come from everywhere else, but since I think I was the only one from Berkeley, my academic background was absolutely perfectly matched to the exam, so that was straightforward. I took it right away and passed it, and decided it was time to go do research. It was still my first year in graduate school, and so I went up to the radiation laboratory where I had been. I went to the cyclotron, and I knew what I wanted to do, and because I had seen other things and hadn't done something that I found interesting, which was single pion production with pions incident on protons, and making what's called the 3-3 resonance. It had never been, and doing that as a function of energy, and that had never been studied, and I knew how to do it from all the equipment that was already there. So I just went, and of course they let me do it because the person that let you was the guy who was running the machine. So nobody said anything, and I didn't have any problem. And I did this, and actually I did it with a couple other students that they were there, and so I thought that was what you were supposed to do for a thesis. I submitted it for publication to PhysRev Letters, and it got published. And then I got in trouble. And the trouble was that I had done all this, but I didn't have a thesis advisor. I thought you were supposed to do independent work as a graduate student. What isn't a thesis supposed to be independent work? I didn't have a thesis advisor, so that turned out to be a crisis. Not for me, I didn't see why it was a crisis, but it was a crisis for the physics department, because you're supposed to have this advisor. And some people, there was a particular faculty member who did his work at the 184-inch cyclotron where I did this, who was terribly offended and felt that I had done something that was illegal, and that the system had let me, and he was just making a big mess. Eventually, the chairman of the physics department interceded, and he was not a particle physicist. He worked in optics. He didn't know anything about it, but he became my advisor and signed my card. So I had somebody that signed my card, and then I got my PhD, and then I got offered a job at Caltech.